Hi everyone. Today we are going to discuss analytic functions in complex analysis. Content, definition of analytic function. That means we are going to discuss the definition of analytic functions. Next topic, Cauchy-Riemann equation, properties of analytic function. Analytic function. The another name of analytic function is regular function, and holomorphic function. Definition: a single valued function f of z is nothing but u plus iv. U is the real part and v is the imaginary part. And this f of z is said to be analytic at a point z0 if it has a derivative at z0. That means it has some derivative. That means f of z has some derivative where at z0 and at every point in some neighborhood, not only here, neighborhood of z0 also. So if this condition is satisfied, then we will tell a single valued function f of z is said to be analytic function. Note, if it is analytic, if it is analytical at every point in a region R, then it is said to be analytic in a region R. So that means what? If it is analytical and at every point in a region R, not only in a such point, the region R, the whole region, then we will tell this f of z is analytic in a region R. So next, necessary and sufficient condition. Necessary condition for an analytic function f of z to be analytic. First, we are going to discuss the necessary condition. Next, we will see the sufficient condition. So, derivation of Cauchy-Riemann equation, that is CR equation. The short form of this equation is CR equation. This is very important. So, that means while discussing in previous slide by the definition, we can easily tell if this condition, that is f of z satisfies the CR equation, then we will tell this function is an analytic function. The statement of necessary condition is nothing but f of z is equal to u of x comma y plus I into v of x comma y is analytic in a region R of the z plane, then it has some partial derivatives for u and v. That means it has a partial derivatives for u. What are all the partial derivative for u? Ux comma uy. Similarly, the partial derivative for v is what? Vx comma vy. So, if this derivative will exist and it satisfies some equation, that equation is nothing but ux is equal to vy and uy is equal to minus vx at every point in that region. This is nothing but CR equation. So that is, this is the Cauchy's Riemann equation. If these two conditions is satisfied, then we will tell this f of z is directly analytic. This is the necessary condition. So, once again I will repeat, that means statement f of z is equal to u plus iv is analytic in a region R of the z plane, then there exists a partial derivative ux, uy, vx, vy exists, and it satisfies the condition ux is equal to vy and uy is equal to minus vx at every point in a region, in that region. Next one, proof. So first, the necessary condition for a complex function is said to be analytic. First derivation. Let us consider the analytic function, that is complex function f of z. F of z is equal to what? U of x comma y plus I into v of x comma y. First we are going to, we first assume f of z is analytic. So okay, if it is analytic, then what is the definition? Then by the definition, it has a derivative. So it has a derivative means what is the derivative of f of z? F of z is nothing but f dash of z, where everywhere in R. That means the derivative will be how? Now f dash of z is equal to limit z del z tends to 0, f of z plus del z minus f of z divided by del z. So yeah, how we are considering? We are considering f of z is analytic in a region R. If it is analytic by the definition, if it is analytic, it has a derivative. Where it has a derivative? Everywhere in R. If it is if it has a derivative means, now how we will write? F dash of z is equal to limit del z tends to 0, f of z plus del z minus f of z divided by del z. Now first let us consider. Now let us consider. We know that f of z is equal to what? U plus iv. So z is equal to what? X plus iy. Z is equal to complex variable and f of z is equal to complex function. So let us consider the variable. Z is equal to x plus iy. Now del z is equal to what? Del x plus I into del y. So now I am going to add these two things. So z plus del z is equal to x plus del x. I is common to both. So I into y plus del y. So now taking both the side. Now we are going to write for the what? F of z plus del z. So f of z plus del z is equal to how it should be? U of x plus del x comma y plus del y plus I into v of x plus del x plus y plus del y. We know that this u, s and v, that is what? F of z is equal to u plus iv. Similarly, here f of z plus del z is equal to u of x plus del x comma y plus del y plus iv of x plus del x comma y plus del y. Now, I am going to use all these in var derivative. So, f dash of z is equal to what? How? The limit. So, del z. This is nothing but del z tends to 0. So, del x plus I del y tends to 0 and I am going to substitute all the values. F of z plus del z. What is the value of this? U of x plus del x comma y plus del y plus iv of x plus del x comma y plus del y minus u of x comma y plus I into v of x comma y, the whole divided by del z is equal to what? This is nothing but is del x plus I del y. The value is this. Just I am substituting all these value in f of z. So I think it's clear for you. Next, now we are going to use the cases. So okay, how let us see. Case 1. If what is that? Del z tends to 0. So we are going to assume that delta y is equal to 0 and del z tends to 0. So how it will be? Therefore, f dash of z is equal to limit del x tends to 0 and substitute all the del y value as 0. So here del y value tends to 0. So y plus 0. So that means u of x plus del y comma y plus 0. So y plus iv of x plus del y comma y plus del y value is 0 minus u of x comma y plus I into v of x comma y, the whole divided by del x plus I into 0. Now, I am going to split the real part and the imaginary part. This is the real part. So, I am going to split the real part and just I am multiplying the minus side in the bracket. So, limit del x tends to 0, u of x plus del x comma y minus u of x comma y plus I into v of x plus del y comma y minus v of x minus y, the whole divided by del y. Now split the values. So limit x tends to 0, u of x plus del x comma y minus u of x comma y, the whole divided by del x plus I into limit del x tends to 0, v of x plus del x comma y minus v of x comma y, the whole divided by del x. Now, the value of this is nothing but the whole term. This is u dash, that is the value, that is del x tends to 0. So, I am going to convert this one as ux. This is partial differentiation with respect to x. And similarly, this term is what? I into limit del x tends to 0. That means what? This term is nothing but partial differentiation with respect to x. So, f dash of z is equal to ux plus ivx. Mark this as equation number 1. I think it's clear for you. Next, case 2. Similarly, we are going to do the case 2. How? Assume del x as 0 and del y tends to 0. So, f dash of z replace del x as 0. So, how it will be? Limit del y tends to 0, u of x plus 0 comma y plus del y plus I into v of x comma y plus del y minus u of x comma y plus I into v of x comma y, the whole divided by I into del y. Next, limit del y tends to 0 or delta y into u of x comma y plus delta y minus u of x comma y plus I into v of x comma y plus delta y minus v of x comma y, the whole divided by I into delta y. and limit delta y tends to 0, u of x comma y plus delta y minus u of x comma y the whole divided by I into delta y plus I into limit delta y tends to 0 v of x comma y plus delta y minus v of x comma y the whole divided by I into delta y. So this is nothing but what? 1 by I into u with respect to y the whole divided by I plus I into this I will get cancelled. V, that is, this term is what? V with respect to y. So f dash of z is equal to how? This is nothing but 1 by I into uy plus vy. So here now I am going to rewrite this equation. How? See, this is the denominator I. So what I am going to do? Multiply and divide it by I. How it will be replaced? Which is equal to I into ui the whole divided by I into I is nothing but minus 1 plus Vy. So, f dash of z is equal to minus I u y plus Vy. Now, by the previous equation f of z, f dash of z in equation number 1, f dash of z is what? Ux plus I Vx, and f dash of z in this here is what? Minus I into Uy plus Vy. So from these two equations, now I am going to compare these two equations. So what we will get? We are going to get Ux plus I Vx is equal to minus I U y plus Vy. Now compare the real part and the imaginary part in the equation. The real part is what? Ux in the left hand side, and in the right hand side Vy. So compare these two and you will get Ux is equal to Vy and Uy is equal to minus Vx. The above equation is called, that is, this is nothing but what? CR equation. We found the CR equation. Therefore, what I am going to conclude, the function f of z is said to be analytic at the point z. It is necessary, that is, it is necessary that it has a 4 partial derivatives. For u, it has ux comma uy, and for v, it has vx comma vy, and not only this exists, and it satisfies the Cauchy-Riemann equation. What is that Cauchy-Riemann equation? Ux is equal to vy and uy is equal to minus vx. So, this is the necessary condition for finding f of z is analytic. Next one is sufficient condition for f of z to be analytic. So, sufficient condition. So, sufficient condition what? The statement of for the sufficient condition, if this f of z, that is a single valued function, the single valued function f of z, and this function is continuous, f of z u plus iv is analytic, where in a z plane, if it has a 4 partial derivative, that obviously it's correct only, no. If it has a 4 partial derivative and all the partial derivatives exist and the function is continuous and it satisfies your equation, then the function is what? Is said to be analytic. That's all. So this is your sufficient condition. Necessary condition is very must. And note that for all polynomials, trigonometric and exponential functions are all continuous. So, you can directly find the partial derivatives and it satisfies CRE equation. Then we will conclude that what f of z is analytic. Next, we will see CRE equation in polar form. So, okay, CRE equation in polar form. So, statement. If f of z, so before we will say Cartesian form, u of x comma y, that is u of x comma y, f of z is equal to u of x comma y plus I into v of x comma y is nothing but the Cartesian form. Now we are going to discuss the CRE equation for polar form. So, okay, the statement. So, f of z is equal to u of r comma theta plus I into v of r comma theta is differentiable at a differentiable where z is equal to r into e power theta. Then, when we will tell this one is CRE equation, satisfy CRE equation, this condition is true. UR is equal to 1 by R into V theta and VR is equal to minus 1 by R into U theta. If it satisfies these two conditions, then we will tell f of z in the polar form is analytic. We are going to prove this one. Let us consider z is equal to r into e power I theta. So, from that what we will tell, f of z is equal to u plus iv. So, u plus iv, now I am going to substitute all these values, that is z u plus iv is equal to f of r into e power I theta. So, this is nothing but what? U plus iv is equal to f of r e power I theta. Now, partial differentiation. We are going to partially differentiate with respect to r, the previous equation. That is, u plus iv is equal to f of r e power I theta. So, u r dou u divided by dou r plus I into dou v divided by dou r is equal to f dash of r into e power I theta into e power I theta. Next, differentiate with respect to, we are going to not only r, we are going to differentiate partially with respect to r and theta. So, same equation, how it will be replaced? U theta plus I into V theta is equal to f dash of differentiation with respect to, that is, we will differentiate. So, we will differentiate f of differentiating f of r into e power I theta. So, differentiate this term f dash of r into e power I theta. Then I am going to do a differentiation for this. R into e power I theta into, with respect to what? Theta. So, into I. So, now it will be replaced at Ri f dash of r into e power I theta into e power I theta. Ri into dou u divided by dou r plus dou v divided by dou r. And next one, Ri into dou u divided by dou r minus r into dou v divided by dou r by the equation 2. Next, equating the real and the imaginary part in this term. So, I am going to equate these two things. So, real and imaginary part. So, this is the real part. U theta is equal to minus r into VR, and the imaginary part is V theta is equal to R into UR, that is U theta is equal to minus R into VR and V theta is equal to R into VR. So, we can replace this one by VR is equal to minus 1 by R into U theta and UR is equal to 1 by R into V theta. So, next example for finding f of z to be analytic. Show that, first problem, show that f of z is equal to z cube is analytic. For that, given, so given z cube is equal to, what is the value of z? X plus iy the whole cube. So now I am going to replace this one into a cube plus 3a squared b squared plus 3ab squared plus b cube formula. Instead of a, here x, and instead of b, iy. Just substitute all these value and separate the real and the imaginary part. So now this is the imaginary unit. The value of I squared will be replaced as minus 1. So just replace this one as minus 1. So these two things are the real part and take this I term as common. So this is nothing but how it will be I cube. The I cube value is I squared into I. So minus 1 into I. So the value will be replaced as minus I y cube. So these two values are what? Imaginary part, and these two values are real part. So x cube minus 3xy square plus I into 3xy minus y cube. Now this is u and this is v. I am going to check the CR equation, and you know that the partial derivative will exist since it is the polynomial. So u is equal to what? X cube minus 3y squared. So ux is equal to 3x squared minus 3y squared, and partial differentiation with respect to y, this term will be what? 0 minus y squared is 2x. So 2 into 3 is 6 minus 6xy. So next vx. So I am going to do partial differentiation with respect to x. So 3 into x squared value is what? 3 into 2 x power 2 minus 1. So 6xy. And next dou v divided by dou y is equal to 3x squared minus 3y squared. So this what? And next one, we are going to check whether this one is analytic or not. See, what is CR equation? ux is equal to vy and uy is equal to minus vx. So it satisfies. ux is equal to vy and vx is equal to minus uy, and this is satisfied. So f of z is equal to z cube is an analytic function. From the above equation we will get CR equation is satisfied, and u and v exist partial derivative, and since it's a polynomial, so this function is continuous. And similarly, the exercise problems are given. Examine the analyticity of the following function and find its derivative. First problem is f of z is equal to e power z. Second problem, f of z is equal to cos z And third problem, f of z is equal to sine hz. First, for solution, f of z is equal to e power z. See, I think it's clear for you. E power z, how I am going to split? E power x plus iy is equal to e power x into e power iy is equal to how? E power I theta. So, e power I theta is nothing but cos theta plus I sin theta. Instead of theta, here y. So that's all. Replacing. Now split the real part and the imaginary part. So multiply these two terms. E power x cos y plus I into e power x sin y. So this is u and this is v. So u is equal to e power x cos y and v is equal to e power x sin y. So u x is equal to e power x differentiation is e power x. So cos differentiation is minus sin. So e y is equal to this term and v x is equal to e power x sin y and vy is equal to e power x cos y. So here it satisfies first condition, e power x is equal to cos y and e power x is into cos y. And second condition also satisfied, uy is equal to minus Vx. So CR equation is satisfied for this problem. That is f of z is equal to e power z is analytic and it has a derivative also. Next, f of z is equal to cos z. So cos of a plus b. Cos of a plus b is what? Cos a cos b minus sin a sin b. Substitute the values cos x cos cos iy is a hyperbolic function. So I am going to convert this one into cos hy minus I into sin x sin hy. So now split the real part and the imaginary part for f of z. So first term is your real part. U is equal to cos x cos hy. V is equal to minus sin x sin hy. So ux is equal to minus sin x, since the differentiation of cos x is nothing but minus sin x cos hy and ui is equal to cos x sin y and vx is equal to minus cos x sin hy and vy is equal to minus sin x cos hy. So now compare this one and here also satisfied CR equation. So the given function is what function? Trigonometrical function. So it is continuous and it has u and v has a partial derivative. Second condition also true. And third one is what? It satisfies CR equation. So the given function is analytic. And we will find f dash of z also. F dash of z is equal to ux plus I vx. So substitute the values of ux plus I vx. Next, you just split the values and what is the value of f dash of z is equal to minus sin z. So this is obviously it is continuous. So next, similarly, here we have one example. You may just go through this one and try it, this one also for you. You are having some problem in polar form also. Check for analyticity of log z. So f of z is equal to log z. So log z is equal to, what is the value of z? R into e power theta, I theta. So you know that log of AB is equal to what? Log A plus log B. So just substituting log R plus log e power I theta. In an exponential, log e both will be cancelled. So log R plus I theta. So we know that f of z is equal to u plus iv. Now we are going to compare the real part and the imaginary part. The value of u is equal to log R and the value of v is equal to theta. So UR is equal to 1 by R. So differentiation of log R is what? 1 by R. And U theta is equal to 0. Similarly, VR is equal to 0 and V theta is equal to 1. So this satisfies, all these functions are continuous and it satisfies the CR equation for polar form. What is polar form? UR is equal to 1 by R into V theta is correct. UR is equal to 1 by R into V theta, correct. And VR is equal to minus 1 by, obviously it's true only, it's everywhere at R except R is equal to 0. That is Z is equal to 0. That is f of Z is analytic everywhere except only one point at Z is equal to 0. So these are all some problems for your kind, check it off. Next one, harmonic function.